if this equation along with the loss function known as mean squared error is forming nothing but linear regression, then we try to extend this equation. So y is equal to mx plus c became y equals to m₁x₁ plus m₂x₂ plus m₃x₃, and so on, mdxd, where d is the dimension of x plus c. Then one more inflection point came when we infused in non-linearity into this equation by using an activation function. The first activation function I ever saw was the sigmoid activation function. Activation function converts all the negative infinity to positive infinity and squishes it between 0 and 1. It has given rise to another algorithm, which is nothing but logistic regression. When I started seeing neural networks come into picture between the 2010 era, neural networks changed everything. They changed speech recognition, image recognition. Then I suddenly realized neural networks are also following the same equation. Some people call it W transpose X, some people call it Wx plus B, some people call it mx plus c, but it's the same line equation. X can be thought of as an input coming from the previous layer, and parameters m and c are still learnable. Calculus said, I will help you differentiate it, use my chain rule. So since I have chain rule, I will help you take the partial derivative of the loss function with respect to all of the parameters possible. When I encounter transformers, I again realize the same thing. Simple line equation has also simplified all the algorithms in general.